Now, we're going to solve the equations given below, and we're going to give three possible numerical values for the unknown variable. In this case, we have the inequality 2 is less than p. In order to make p the subject of this inequality, we want p to be isolated on the left hand side of the inequality, and we want p to be the only term of the left hand side. And this can be achieved by swapping the position of the left hand side term and the right hand side term. Doing so gives p on the left hand side, 2 on the right hand side, and remembering to reverse the inequality symbol, the less than sign symbol becomes the right hand side symbol. So the solution to this inequality is p is greater than 2, i.e. we have the possible values of the variable p. P can take values greater than 2. For example, p can be 3, can be 4, and can be 5, because these are all values greater than 2. So this is the solution. P is greater than 2, and possible values of p are 3, 4, and 5. So I'll write 5, 3, 4, and 5. So here's our solution to the inequality, and here are three possible values of p. Here's another inequality. The inequality m minus 5 is greater than 7. In order to solve this inequality, we need to determine a value or values for this variable m that causes this inequality to be satisfied. So we need to make m the subject of the formula. So let's drop the brackets to give m minus 5 is greater than 7. Adding 5 to both sides gives m minus 5 plus 5 is greater than 7 plus 5, which gives m minus 5 plus 5 is 0, so greater than 7 plus 5 is 12. So valid values of m are numbers greater than 12. For example, m can be, let me put it this way, m can equal 13, 14, and 15. And let's test this result. Or let's even numbers like 20, 30. Once the number is greater than 12, it's a valid value. But the question only asks for three possible values, three possible numerical values, so you can give any of these three. So let's test 20. When m is 20, this left hand side term is as follows: 20 minus 5. 20 minus 5 is, and the right hand side term is 7. 20 minus 5 is 15, which is greater than 7. So when m is 20, the left hand side is greater than the right hand side. So this inequality is satisfied. When m is 30, the left hand side becomes 30 minus 5, which is 25. The right hand side is 7. As you can see, 25 is greater than 7, and the inequality requires m minus 5 to be greater than 7. When m is 30, m minus 5 is 25, which is greater than 7. So the inequality is satisfied. So as you can see, here's the solution. M takes values greater than 12. Here's another inequality. 8 less than x plus 1. And we need to solve this inequality, meaning that we need to determine the value of this variable that causes the inequality to be satisfied. So the procedure is to make the variable, in this case x, the subject of the formula. We want to make x the subject of this inequality. So we want to isolate x on the left hand side. This can be achieved by first swapping the left hand side and right hand side terms. This gives x plus 1 on the left hand side and 8 on the right hand side. The initial inequality symbol is the less than symbol. Because we swap the left hand side and right hand side term, remember we have to reverse the inequality symbol, so less than becomes greater than. Dropping the brackets gives x plus 1 greater than 8. In order to isolate x, let's get rid of this plus 1, so let's subtract 1 from both sides. Gives x plus 1 minus 1. 1 minus 1 is 0, so that's x plus 1 minus 1, which is x plus 0, greater than x. 8 minus 1 is 7. So we have x is greater than 7 as the solution. And three possible values of x are any three values of x that are greater than 7. So x could be 8, 10, and 20. Now let's test these results. Let's test x is equal to 10. Now when x is 10, this is our original inequality. The left hand side is 8. The right hand side is x plus 1. So when x is 10, the right hand side is 10 plus 1. 8, 10 plus 1 is 11. 8 is less than 11. As you can see, the inequality requires 8 to be less than x plus 1, which it is when x is 10. If you try replacing x with 20 and try replacing x with 8 and check to see if the inequality is satisfied. Check to see if 8 is less than x plus 1 after you've replaced your x with any value of x that's greater than 7. So try x is 8 and x is 20, and you find that the inequality is satisfied. So try this. Here's another example. We have the inequality 2p plus 5 is less than or equal to p. This inequality only involves one variable, the variable p. Even though p appears twice, there's just one variable, p. It's not like a case where we have 2p plus y is less than 5. Here we have two different variables, p and y. Here we just have p, and we need to make p the subject of the formula in order to solve this inequality. This can be achieved by grouping all the p's together, and we want to isolate p on the left hand side. So let's subtract p from both sides. So let's get rid of p on the right hand side so that we can just have p on the left hand side. This can be achieved by subtracting p from the right hand side. But whatever we do to the right hand side of this inequality, we must do to the left hand side. So 2p plus 5 minus p less than p minus p. We're subtracting p from both sides. So the inequality symbol does not change. Grouping all the p's on the left hand side gives 2p minus p plus 5 less than p minus p is 0. 2p minus p is p plus 5 is less than or equal to 0. Now, so in order to isolate p on the left hand side, let's get rid of this plus 5. So let's subtract 5 from both sides. Simplifying gives, well, p plus, what's 5 minus 5? 0. Less than or equal to 0 minus 5 is minus 5. Simplifying gives p is less than or equal to minus 5. So the values of p which satisfy this equation are values of p, the numbers that are less than or equal to minus 5. So possible values of p equals minus 5, because it was saying less than or equals to minus 5, p equals minus 6, and p equals minus 7. All these numbers are such that they are less than or equal to minus 5. So they satisfy this solution. So this is our solution here. And these are three possible values of the inequality given here. All we had to do was make p, the unknown variable, the subject of the formula. Here's another inequality. This time on the left hand side we have an algebraic fraction. Here's the numerator, here's the denominator. In order to solve this inequality, which is an inequality in one variable, the variable x, you need to make the unknown variable the subject of the formula. So at first, let's get rid of fractions. Let's get rid of the 2 in the denominator by multiplying both sides by 2. So multiplying both sides by 2. 2 cancels 2 here, it gives 1. So on the left hand side we have 1 times x plus 1, which is x plus 1. It's greater than 2 times 3, 6. In order to make x the subject of the formula, subtract 1 from both sides. 1 minus 1 is 0. 6 minus 1 is 5. So we have x is greater than or equal to 5. And that's the solution. So the three possible values for x are 6, 7, and 8. Or you could also say 5, 5, 6, and 7. X can be 5 because the inequality says x is greater than or equal to 5. So x can be 5 and any number greater than 5. Here's another example. The inequality minus x plus 3 is greater than or equal to 1. You're required to solve this inequality and give three possible values of the unknown variable. In other words, we need to make x the subject of the formula. So we have a minus x term here. So let's get rid of the plus 3. Let's subtract 3 from both sides. Simplifying gives minus x plus 3 minus 3 is 0. That's a plus. Greater than 1 minus 3 is minus 2. So we have minus x is greater than minus 2. We want to isolate x on the left hand side, but here we have a minus x. So to get rid of this minus, let's multiply both sides through, or let's multiply this inequality through by minus 1. So multiplying the left hand side by minus 1 gives this. Multiplying by the right hand side by minus 1 gives minus 1 times minus 2. Because we're multiplying an inequality through by a negative number, the inequality symbol, the initial one, has to be reversed. So greater than becomes less than. Minus 1 times minus x is x. Less than minus 1 times minus 2 is 2. So the solution to this inequality is x is less than 2. Possible values for x are 0, 1, and minus 3. All of these values are less than 2. Here's another example. So required to solve the inequality given here. 2 open bracket x plus 1 close bracket less than 3 open bracket x minus 3. It looks complicated. So to start with, let's simplify the left hand side term here and let's simplify the right hand side term here. 2, expanding this term gives 2 times x, 2x, noting the sign, plus 2 times 1, 2. the less than sign. Let's expand this expression. 3 times x is 3x. Let's note the sign, which is a minus. 3 times 3 is a 9. So we have 2x plus 2 less than 3x minus 9. Let's isolate the x on the left hand side. Let's group all the terms involving x on the left hand side, because ultimately we want only x on the left hand side. So let's do that to start with. So let's get rid of the 3x on the right hand side. So let's subtract 3x from both sides. 2x plus 2 minus 3x is less than 3x minus 9 minus 3x. I can group all the x terms to give 2x minus 3x plus 2 is less than 3x minus 9, which gives me 2x minus 3x is minus x plus 2 is less than 3x minus 3x is 0 minus 9 minus x plus 2 is less than minus 9. I want to isolate x on the left hand side, so let's get rid of this plus 2. Let's subtract 2 from both sides. So I'm subtracting 2 from both sides. This gives minus x plus 2 minus 2 is 0. Minus 9 minus 2 is minus 11. So I have minus x is less than minus 11. I just want to isolate x on the left hand side because I'm making x the subject of this inequality. So let's multiply through by minus 1 to get rid of this minus. Multiplying the left hand side by minus 1, a negative number, gives this. Multiplying the right hand side of the inequality by minus 1 gives this. Because I multiplied this inequality through by a negative number, I have to reverse the inequality symbol. Simplifying gives the following: minus 1 times minus x is x, minus 1 times minus 11 is 11. So solution is x is greater than 11, so x can take numerical values greater than 11, such as x can be 12, x can be 13, x can be 20. So these are 3 possible values for x. Here's a final example and a question you could potentially face in an exam. It says solve the 2 inequalities below. So we're solving 2 inequalities. This one, call this inequality 1, and this one, inequality 2. And give values of x that satisfy both inequalities. So what we're going to do is we're going to solve each inequality separately. And we know how to solve inequalities involving one variable. We just make that unknown variable the subject. So for inequality 1, which is 3x minus 4, which is less than 5, we make x a subject of the formula. So let's get rid of the minus 4. So we can just have the term involving x. 3x, this gives 3x minus 4 plus 4 is less than 5 plus 4. So we added 4 to both sides. This gives 3x is less than 9. Dividing through by 3 gives x is less than 3. So this is a solution to the first inequality. X takes values less than 3. Now let's look at the second inequality. It says x minus 1 is greater than 0. In order to make x a subject of this inequality, all we have to do is isolate x on the left hand side. So let's get rid of this minus 1. Let's add 1 to both sides of the inequality. 0 plus 1. X minus 1 plus 1 is 0. 0 plus 1 is 1. This gives x is greater than 1 as the solution to the second inequality. And in case anyone's confused about this step here, x minus 1 plus 1 is the same thing as x plus 1 minus 1. You can just rearrange the terms, which is x plus 1 minus 1, 0, which is x. That's another way to do it. So moving on, the first inequality has a solution, x is less than 3. The second inequality has a solution, x is greater than 1. And we're required to give values of x that satisfy both. So what values of x are less than 3 and also greater than 1? So let's look at the first inequality. The solutions of values of x that are less than 3. So 2, let's look at the integer numbers now. 2, 1, 0, minus 1, and so on. For the second inequality, we need values of x that are greater than 1, such as 2, or let's even go here, 2, 3, 4, 5. So which values, and we can go here as well. So there's no value here. There's no, well, if we're just considering whole integer numbers. So which values are in the solution set of both solutions? So these are the solutions to this, and these here are solutions to this. 2. Another way to put this is to just look at a number line. So where's 1? If 1 is here, we have 2, and we have 3, we have 4, and we have 0. when x is greater than 1, we have solutions in this region. So I'm going to shade the region x is greater than 1. So numbers like 2, 3, 4, 5, and so on satisfy this inequality. For the second inequality, x is less than 3, we have to be in this region, x is less than 3. So we have to be in this shaded region. So the region where both solutions intersect, which is the region between 1 and 3, gives the solutions to both inequalities. So solutions lie between 1 and 3. So 2 is an example, 1.1, 2.4. So any solution between 1 and 3 satisfies the inequality. So an example, a possible value, or let's see, give values of x to satisfy both inequalities. So x could be 2, x could be 1.2, x could be 2.4, as long as x is greater than 1 and less than 3. 2 is greater than 1 and less than 3, 1.2 is greater than 1 and less than 3, 2.4 is greater than 1 and less than 3. So if this shading approach is confusing, you can ignore it. If this listing approach of solutions is confusing, you can ignore it. All you have to do is just say, okay, well, x has to be greater than 1 and x has to be less than 3. What numbers are greater than 1 and less than 3? Well, 1.2 is greater than 1 and it's less than 3. Or rather, what numbers lie between 1 and 3? Excluding 1 and 3. 1.1, 1.2, 1.3, 2, 2.4, 2.5, those kind of numbers. And that's the solution to this problem.